So in today's lesson we're going to look at polynomials. Now polynomials is just a term to describe something with multiple numbers in it and multiple powers. And as you can see from the example here, this is what a polynomial is. This is the textbook definition of a polynomial. I don't expect you to know all the details of it, but I'll talk you through it. So the p bracket x you can recognize as our function notation. P in this case stands for polynomial and is just a generic way of saying anything with an x as a variable. Now this is a definition, remember, so this is what a polynomial will look like, replacing the a with a number. Alright, so here we have the first term, which is a. Now the n at the bottom is just a label. It just means that if this, in this case, this n here would be number 1, and it should mean that it's the first coefficient. Over here you'd have n minus 1, and you'd have the second coefficient. So this first term has a coefficient, an x term, and a power. The second term has a coefficient, an x portion, and a power. And it just keeps going. It can keep going. It doesn't have to. It can have one term, or it can have 3 terms, or as many as it wants. There are a few restrictions on these polynomials. So n, or the power, must be a natural number. And you might remember that natural numbers were the counting numbers, and it couldn't include 0. So it has to be a whole counting number. That's the power, has to be a whole counting number. Alright, so that's the first restriction. That's the only restriction, but the other thing we have to look at as well is what's known as the degree. So the degree is just a way of saying what's the highest power in this polynomial. And generally we look at the lead term, but sometimes they will be muddled up or mixed up. So the degree is the highest power. For instance, if we had a polynomial that was x squared plus 2x, we would say its degree was 2. It's a second degree polynomial. If we had a polynomial that was x to the power of 7 plus x to the power of 6 plus 3x to the power of 4, we would only look at the highest term. In this case, it's the first one. It's x to the power of 7. So this is a 7th degree polynomial. Another term we need to remember is the word monic. Now monic means when the first term has a coefficient of 1. So if you look back here at these two polynomials on the left at the bottom, x squared plus 2x and x to the power of 7 plus x to the power of 6 plus 3x to the power of 4, you can see that the first term in each case has a coefficient of 1. So these ones would be known as monic polynomials. Now, in what we can do with polynomial notation, or which you should already be realizing, is that when we write a polynomial like this, we can then just quickly say, or ask, what is p when x equals 1? What's the polynomial worth when x equals 1? And what this would mean is that we would substitute 1 in place of x every time. So you can clearly see that 1 is just going to sit in place of x each time, and it's going to produce a 1 minus 3 minus 2, which is going to be, what's that, minus 5 minus 4. So p when x equals 1 equals minus 4. Now, what I kept telling you earlier in the year was that these questions are really easy to do when you use your CAS. So if I were you, I would be using your CAS to do these type of questions by first of all writing down the function, which we remember is just the x4 minus 3x cubed minus 2. Then you would hit your interactive button, then define. Now the calculator will automatically put in f with the variable of x, but you can specify any letter you like. You'll notice that in this chapter they use p for polynomial. Another common one is capital Q, as is the next letter of the alphabet, just like we talked about there being f of x, g of x, h of x, and you can choose any letter you like, so long as you remember that you've used that when you go on to the other questions. what you'll start to see now are questions involving one polynomial, this one here, and then they'll ask you a series of other or subsequent questions. The first one being, what is p when x equals 1? What is p when x equals minus 1? What is p when x equals 2? And what is p when x equals minus 2? And if you, I'm a little bit lazy, if you're like me, you don't want to be calculating all of these steps by hand. You want to be able to do them on your calculator. And it makes a lot more sense if you can just type in these commands here and have the calculator do your work for you. So far through function notation and then putting it into a slightly different terminology using polynomials, it's really okay with entering it onto the calculator because it will make your lives a lot easier. Now in this example, we've been given a polynomial. You might notice that it's got a c, or an unknown, in the third term or the second last term. So 2 times something times x plus 6. Now this other information here, it says if p when x equals 1 equals 21, find c. Now I'm going to show you what to do in these type of questions. They've just given us all the information we require to solve it. And what you're going to do is you're going to write it down. P1 equals, and then everywhere you see an x, you're going to chuck a 1, just like we did in the previous example. And you might notice that the c is not an x, so we're going to leave it there. That should be a 6. Now it said that p when x equaled 1 was 21, which means that this left-hand side here, we can substitute out for the number 21. So we've got 21 equals 2 times 1 minus 1 plus 2c plus 6. Now I've simplified some things, but not others, so 1 to the power of 4 was 1, so I've just left it as 1. The next step, 2 times 1 is 2, minus 1 plus 2c plus 6, and you can see here, can't you, that all I'm going to be left with on one side is the term involving the c, which is what I want to do to be able to solve for c. So one step at a time, I'm going to move the other three numbers, the 2, the minus 1, and the 6, across to the left-hand side, leaving me with this term 2c. Once I've got it simplified like this, I'm going to divide both sides by 2 to get c by itself, which is going to leave me with c equals 7. Now the final step, as we remember from function notation, would be to put it back into polynomial form, but it's not necessary because the question has asked us to find c equals 7. However, I personally like to put it back into that form just to make it a little bit more finished. But unless the question is asked for it, oops, now remember when doing this you have to expand out the 2c because c equals 7, so that becomes 14x plus 6. So if the question has asked you to put it back into polynomial form, do that. Otherwise, just go with what the question has told you to do, which in this case was find c. For all the knowledge, we get quite familiar with using the polynomial notation or the function notation, particularly things like this, p bracket 1, and the last. Now here we have two polynomials, the first of which is px equals x cubed minus 6x plus 3. The second of which is qx equals x squared minus 3x plus 1. You might notice that the qx is a second degree polynomial or a quadratic, and px is a third degree polynomial, which we'll find out later is called a cubic. Now, we can do many other operations with these. The three we're going to look at right now, though, are addition, subtraction, and multiplication, and they are actually quite straightforward. So if the question gave you two polynomials like above and asked you to do something like this, px plus qx, you would really just write out px as you were given, put a plus between it, and then write out qx as you were given. Now, the key to doing this is to collect your like terms. This is going back to year 9 maths, so we've got there's no like term for the x cubed, there's no like term for the x squared, but there are like terms for the x and the constant. So I'm going to underline them in two different colours so we can see which ones are which. So the constants are in blue and the x terms are in red. Now all I'm going to do is I'm going to collect those and simplify. So the first one there was no like term for, so it stays as is, x cubed. The second one, or the next highest power, is x squared, no like term, so it stays as is. The next one is minus 6x minus 3x, so I combine them to become minus 9x, and the last one is going to be 3 plus 1, which is 4. So all I've done is I've collected the terms that are able to be collected, the like terms, and combined them. And I've got my new function, which I can give a separate label to if I want to, or I could just show that that's the working out I've done to arrive at the answer. Now in this example, it's asked us to subtract qx from px. It's exactly the same as before with the addition, however you do have to remember that the subtract sign works on the entire qx polynomial rather than just the first term. And I'll show you what I mean. So first of all, like before, I'm going to write down my px plus 3. I'm going to put a minus sign. Now the minus sign means I subtract everything in the qx, so I'm going to put brackets in so that I don't forget that the minus sign affects every term. My next step is I'm going to rewrite px at the front, and I'm going to expand these brackets so it becomes minus x squared plus 3x minus 1. Now it's important to remember that step because it's going to affect the answer, obviously. So again, I have to underline my like terms, and you might remember that x cubed and x squared didn't have any. So I have 6x and 3x, and I have plus 3 and minus 1. You'll notice from the addition and the above example that now their signs have changed, so it's going to give us a slightly different answer. So now I simplify and write down what I need to. X cubed minus x squared minus 3x plus 2. So there you have it. You can do addition and subtraction. The other thing you can do is multiplication. I'm not going to show you that example, but it really just means that you would be multiplying everything in qx by everything in px, and you would use your FOIL method to do that. However, do remember that all of this, if you defined your two functions on your CAS at the start of the question, you would be able to just, into your CAS, enter these headings here. Px, take away qx, and the CAS would spit out the answer for you. Px plus qx, and the CAS would spit out the answer for you. So here is a prime example of why defining those functions is going to make your life a lot easier. Just utilizing. Also, please make sure to remember is that we're going to look at equating polynomials now, and this is a fairly common sense idea, but you'd be surprised at how many people don't quite understand it. It just says that two polynomials are equal only if all the coefficients are equal. Now, I'll show you an example. It might mean something like, it could mean something like this, equals 2x squared. You can clearly see that those two are not the same. The coefficient of the first one is 1, and the coefficient of the second one is 2. Therefore, these two coefficients are not equal. So this rule is kind of something I don't really have to go through in all that depth, because you can see that if I tell you that these two are the same, you can automatically assume that 3 is the same as A. So we're going to use this kind of knowledge to actually help us to solve some problems. In the two polynomials in the blue box, I've got px and qx. Now you can see in qx that I've only got variables in here, b, c, d, and e. However, we're going to use our knowledge of equating to actually work out what b, c, d, e, and r. Alright, so if we were told that px is the same as or equal to qx, that would automatically mean that all we had to do was match up the corresponding terms, and we would have our variables. So there's 4x cubed is the same as bx cubed, so therefore b equals 4. We have cx squared is the same as 5x squared, so therefore c equals 5. We also have dx is the same as minus x, so therefore d equals minus 1. We also had the last one that 3 was the same as e, because it's the constant, so therefore e equals 3. So if we then put that information back into q of x or qx, we would just substitute those numbers that we found into the places of the b, c, d, and e. The only thing you have to remember when doing this is that you've chosen the corresponding terms with the corresponding powers. For instance, you wouldn't want to tell me that 5x squared was the same as bx cubed, because that x term and this x term have different powers and are not like terms. So again, this goes back to your idea of like terms and matching up the ones that are alike with the other corresponding one that is alike. Now in this problem, it's given us a polynomial. It says that px is equal to x cubed plus 3x squared plus 2x plus 1. Then it's gone on to say that this polynomial can be written in the form like this, and it's x minus 2 multiplied by x squared plus bx plus c, and then tacked on at the end is plus r. Now it actually has also asked us to find the values of the variables b, c, and r. So this is what it wants us to find: b, c, and r. Remember, it's told us that p of x can be written like this, the factorized form this is called. So what I'm going to do is I'm going to show you a way to solve it and find out what b, c, and r are. Now the first step I'm going to do is I'm going to expand out the second of the brackets, and I'm going to do this using FOIL so that everything in the first is multiplied by everything in the second. So you can see here that the blue lines give me a multiplication. X times x squared gives me x cubed, x times bx gives me bx squared, x times c gives me cx. The same for the green. Minus 2x squared is over here, minus 2bx is there, and minus 2c is there. The plus r wasn't multiplied by anything, so it just gets tacked on the end. The next step will be to simplify each like term if possible. So what I'm looking for are terms that have a like in the blue and the green, and I can combine them if possible. So you can see here that I've got a cx and a bx, and what I'm looking for is like terms that have the same x power. Alright, so I've got an cx and bx are two terms that I could combine if I knew what c and b were. I'd have bx squared and 2x squared. If I knew what b was, I could combine that with the other. As it stands, I don't know what b and c are, so I'm just going to write those like terms next to each other. You can see here that what I've written, that the x cubed didn't have a like term, so it sits at the front. I have the 2x squared terms next to each other, 2x terms next to each other, and the two constants next to each other. And I just realized that should say c and not x. My mistake. So now what I'm going to do is I'm going to factorize each pair of terms so that the x, or the x squared, is sitting by itself just like it is up in the original polynomial at the top right of screen. I have x cubed sitting by itself. I have 3x squared. What I'm looking to do is get the x term away from its coefficient. So that next line down, you can see that the x cubed didn't have a like term, so it sits at the front. The x squares. Now the 2x squares had the common factor was an x squared. That's in both, so I can divide both by x squared, and I'm left with b minus 2 inside my brackets. The same with the x, divide both by x, and I'm left with c minus 2b inside my brackets. The minus 2c plus r I will leave as is at the moment because there's no x terms to do, so there's nothing to factorize. Now, the next step, I've written both polynomials. The original one I was given is in the red. The one I've found is in the white. And the reason I've written them above each other is so that I can actually, I'm going to put a circle around the group of terms that are alike. So I'm going to say those two terms are the same. I'm going to say that these two terms are the same, these two terms are the same, and these two terms are the same. Now remember, the goal of the question was to find out what b, c, and r are equal to. And the way we do that is by equating the two forms of the polynomial, match up the coefficients, and that should tell us what b, c, and r are worth. Now there's one more step, or a couple more steps to do in finding out what b, c, and r are, and it's going to involve solving and matching up the coefficients. So as you can see here, the white x cubed is the same as the red x cubed, but there's no variable there, so we don't need to worry about that one. Over here, I have b minus 2, and because it's the coefficient of x squared, I can say that b minus 2 is the same as 3. So you can tell me what number minus 2 has to equal 3, and you can clearly see that b should equal 5. Alright, now moving on, we can see that c, take away 2b, has to equal 2. We already know that b equals 5, so 2 times 5 is 10. A number, take away 10, has to equal 2, so therefore c must equal 12. Now the final one, the coefficients that or the variables I've circled down here, this whole end, 2c plus r, has to be the same as 1 because there's no other terms in the end of the red polynomial. So these three things together have to combine to produce a value of 1. So we already know what c is. C equals 12. So the final thing to do is to match up the three terms at the end, and I've just made a mistake. I realised that plus should have been a minus way back from here. So I have minus 2c plus something equals 1. I already know that c equals 12, so it becomes minus 2 times 12, which is minus 24, plus something equals 1. So I have minus 24 plus r equals 1. So therefore, if I move the 24 across, it becomes positive, and I can see clearly that r equals 25. So there, I've answered my question. I've used equating polynomials to do it. I've been able to make the second polynomial look like the first, match up the coefficients, and solve for what they were worth. And I noticed that I had to use the b value to find the c value and the c value to find the r value. So these type of questions will require you to be quite thorough in your approach and make sure you're checking every step to make sure there's no mistakes. So this lesson is really every step for errors, because these type of questions, if you make an error back in step 1, it will just flow on and you'll end up with the whole question wrong. Now in methods that's fine because we can give you marks based on your approach, but it is better that you erase all those errors as early as possible to make sure that you get the marks for the answer as well as the marks for the process. Always remember that if a question is worth more than 1 mark, you will have to show some process steps to ensure that you're getting every possible mark for that question.